Hi everyone, welcome to Felix the Analyst channel. Today we'll be discussing about using R programming language to do some basic data analysis. So the first thing here we'll be discussing today is basics of what R programming, then RStudio. R was developed in the year 1993 by Rose Hacker and Robert Gentleman. So when you are coding on the normal R environment, it is not as flexible and robust as what RStudio. RStudio was developed to make it efficient in such a way that when you are coding, it will be bringing up some suggestion, it will be making you code faster. So now another thing we want to talk about today is CRAN. What is CRAN? CRAN is the Comprehensive R Archive Network. This is a place where all the R resources are stored online, so that if you need anything, once you go to the CRAN website, you will get whatever you need about R. So the next thing we need to discuss here is RStudio. R packages. What is the packages? We have two types of packages. We have the base package and then we have contributed packages. So for the base package, these are the packages that once you install R programming language software, it comes with it. You don't need to start installing it again. But for the contributed ones, you need to install it when you need it. So, and another thing is that we went ahead to talk about the command you can use to install a package. If you want to install a package, you write install.packages, and here is the package. You bring in the package you want to install in between the quotes and then open and close your bracket. So when you load this command, it will automatically link your RStudio up to the CRAN website to now install the required package, which is tidyverse in this example. So, but another thing you need to make sure you have is that your system have internet access while you are doing that, because without internet access, it will not connect to the CRAN website. So now, after you've installed your package, it's something you just do once. You don't need to do it again, unless there is an update on that particular package, then you reinstall it. So, but once after installing, automatically the package will not be active for you to use it in our environment. So anytime you want to use it, you need to use a command called library. Then you bring in the name of the package. In this case, the package is tidyverse. Then you use library. When you load this command, it will activate that particular package for usage. So, and after you are done with your analysis and you close down your R software, when you open it the next time and you intend to use this particular package, you still need to load it again using library or require. So these are the two functions you can use to load your package anytime you want to use it. But for the installation, it's something you just do once. You don't need to install it again unless there is an update in that particular package. So now I want to quickly discuss about a package called Pacman. What Pacman does is that you can understand here that first we need to install the package and then we need to still load it again. But using Pacman, Pacman will install and then load it for you automatically. Then already, if you've already installed those packages, Pacman will also go ahead and load all of them at the same time. So now, how do you go about it? When you write install, first thing you need to do, install the Pacman. After installing the Pacman, then use this command, Pacman $p_load, then open and close brackets. So when you've done that, then add all the relevant packages you want to load or you want to install. So you can see the first thing I brought here is Pacman. I want Pacman to load itself and then load all these packages here. You can see there are numerous packages here. If I really want to load them one after the other, it will take a long of time because I need to be writing library dplyr, library gggali, library ggplot2. It takes a long time, but you can quickly write all of them here and Pacman will go ahead and load them if they are already installed. But if they are not already installed, it will still go and install it and also load it. You see that it's doing two jobs at the same time. So that is by the way, and I want you to take note of the packages that I'm using here, because all these packages are relevant for this tutorial. So if you are following this tutorial, make sure you have all these packages loaded. So if I go ahead, even though I've already installed all these packages, so if I'm loading this command, all it will do is just to load it for me. Or if you've not installed this package, all you need to do, connect your system to internet and then bring all these relevant packages. Pacman will install it and also load it for you. It will do the two jobs at the same time. So I'll go ahead and load it. So when I've done that, another thing I want to quickly discuss that what if you want to unload some package? How you do it, you use p_unload. Then you can list the name of the packages you want to unload. Then it will go ahead and load those selected packages. But if you want to unload all of them, you can use ALL, that is all, p_unload, then put all. It will unload every packages. So now another thing we want to talk about is that what if you have a base package and you want to detach it? A base package, for instance, I am interested in the package called bit. If I load this bit, you can see in the console it gave me the code that it is library open and close bracket bit. So let's say I've loaded it. What if I want to detach it? You use this detach, you open and close brackets, then you declare the package. And what is the name of the package? It is bit. Then I'll cover it with quotation. Then I'll say the command unload equals to what? True. So if that is the case, if I load this thing, you can see that it has been it will detach it. And you notice something here. Formerly it was ticked. The detaching it now remove the mark. It has unticked from here. So that is it. So now another important thing we want to discuss is what we call the arrow shortcuts. When you write Ctrl+1, if your cursor is not anywhere to be found, when you write Ctrl+1, it brings your cursor to your script, that is the source editor. When you write to it, then it goes to the console, help, history, file, and up to 9, the viewer. So in this case now, but another thing I want to mention here before I proceed is that instead of writing Ctrl+1, when you say Ctrl+Shift+1, it will enlarge that particular pan for you. So for instance, if I write Ctrl+Shift+1, it will expand my script. Ctrl+Shift+2, it will expand my console. So let's quickly look at it. So let's say for instance, I don't know where my cursor is not anywhere. When I say Ctrl+1, you see my cursor became active in the script. Ctrl+2, it became active in the console. Ctrl+3, it goes to the help. Ctrl+4, it goes to the history. Ctrl+5, it goes to the file. Ctrl+6, it goes to the plot. Ctrl+7, it goes to the packages. Ctrl+8, it goes to the environment, and Ctrl+9, it goes to the viewer. So this is how it looks like. So without wasting our time, so and the next thing I said again, what if I say Ctrl+Shift+1, it will expand the script. Ctrl+Shift+1, it takes it back. Ctrl+Shift+2, it will expand the console. Ctrl+Shift+1, it takes it back. So this is how you can expand and bring it back as much as you want. So having said that, the next thing I want to talk about here is arrow help. If you're working on R and maybe you are confused about something, all you need to do, put a question mark and type whatever you're confused about. R will go ahead to tell you what it is. So for instance, I don't know what tidyverse is. When I put question mark in front of it and I run it, so it will go to the automatically it will tell me something. This is a help. What is the help? This thing I think is 3. I'll say Ctrl+Shift+3. You see it will expand the help view. So now it says that tidyverse is a set of packages that work in harmony because they share common data representations and API design. This package is designed to make it easy to install and load multiple tidyverse packages in a single step. It went ahead to give you some links and maybe the authors and other relevant information you might need about that particular thing. So that is how you go about seeking help in our environment. Then another one I want to quickly discuss is how do we clear the arrow memory after we are done with our analysis. For you to clear the environment, you use this command. Then for you to clear the console, you use this command or shortcut Ctrl+L. Then for you to clear the plot, you use this command. For instance, I have something on the plot. This is the plot. What if I want to clear it? Once I load this command, you see it clears the plot for me. So now that is by the way. Then another thing I want to quickly talk about is working directory. You can use a shortcut to access your working directory. I've already made a video about working directory. and what it is used for, why it is useful that you set it up before your analysis. So if you want to really know more, go and watch that my video. So if I say Control Shift H, it will quickly open up it will open up for me to select a folder for the working directory. So if I am interested in the desktop, these are the folders in the desktop. I can go and pick any of them. Then if I am not I need a new folder, I can create a new folder and I can then save it. It becomes automatically becomes our working directory. Okay, so that is for that. So we'll go to the section 2. Section 2 is talking about data understanding. How do you understand the data? Listen, you have imported your data into our environment and you don't even know what the data looks like. So how do you go about understanding your data? So how you go about it is the first thing you need to do is what you say. We use view. In these packages that I installed earlier, you will notice a package called datasets. So this dataset contains a lot of data we'll be using for this tutorial. So, and one of them is iris. So let's say a new tab. Let me go back. If I said it will open up a new tab for me. When it opens up a new tab for me, you can see it has 1, 2, 3, 4, and 5 variables, and I found out that the 4 of them are numeric variables, and then one of them is categorical. So if I go back, what if I use head? Then I can, by default, you can use head iris. It takes you the first six observation. Or if you are not interested in that, if you want to see more, you can say, okay, give me 12 first observation. It will give you up to the 12th observation, as you've seen. Then what is str? It talks about structure. Then if I talk about the structure, is look at what it displays here. It said that this data is in data frame format and it has 150 observation. It has 5 variables, and look at the variables. It said that these ones are numeric, and then the last one species is a factor of 3 levels. So what if I go ahead and use glimpse? If I use glimpse, you can see it has 150 rows and 3 columns and 5 columns, and then it has these variables, and it also has species. So what if I want to now find out the mean of a particular variable? Now something happened here. This is there's a code inside here. For instance, if what this thing means is that the data we are talking about is called iris. If I write iris and I'm interested in a particular variable contained in the iris, so all I need to do is that I will use $sign. When I use $sign, it will suggest all the variables, so I can select any one I'm interested in. So that is what we did here. Say that go to the data called iris. When you get to the data, select a variable called sepal.length, and it is a numeric variable. That means we can get the mean. So on that note, what is the mean? It tells us what is the standard deviation of that particular variable. Is it? What is the median? What is the IQR? That is interquartile range. This is it. What is the summary? You notice something in the summary. Control Shift. So now in this summary, it goes ahead to give us the minimum, the first quartile, the median, the mean, and the third quartile, as well as the maximum value. So it gave us all these things for each of the variable, but the last variable, because it is a factor, it gives us the frequency. It tells us that we have setosa is 50, versicolor is 50, and then virginica is 50. So let's go back. So having done that, I can go to the what if I asked what is the class of species? It's telling me here is a factor. Then what if I then another thing is that for a categorical variable, you can always show them in table. If I ask for the table, look at it. It says setosa is 50, versicolor is 50, and virginica is 50. Then another thing you can use is to describe, because describe contains more information like the skewness, the kurtosis, the standard error. It's contained in the describe. So before you can use this describe, make sure this package is active. DPLYR. You can also see in the packages that I loaded, is it here? It's already loaded. This is DPLY. So if you want to use this describe, so all you need to do, describe what data arrays. If I described it, Control Shift 2. So you can now see that it listed the 5 variables, 1, 2, 3, 4, and 5. Then he gave us that we have 5 variables. We have the n, the number of observation, they are all 150 equal. Then we have mean, we have the standard deviation, we have the median, we have the true median, we have the mad mean, absolute deviation, we have the minimum, maximum range, skewness, and the kurtosis, and the standard error. So you see that it contains information. So the next thing we want to talk about, developing what data. How do we go about it? Let's say, for instance, what this stands for is that I want to assign what is on the right hand side to what to the left hand side. For equivalent, if I go ahead and say here x is assigned to what 4. If I load it, I will now understand that x is equals to 4. So if I go ahead and ask our x, what is x, to tell me is equal to 4. So what it means here, we are assigning whatever is on the right hand side to the left hand side. So, and the first thing here is C, is called concatenation. Use it to bind. So now, and if I've done that, and I want to also create another variable called age, and I will assign these values to the age, simply means that Emma is 23, Chima is 32, and Ekene is 31. So remember that as I've done this, all of them are separate. What if I want to combine it into a format that I understand the best, which is data frame? All I need to do, I will use a function called data frame, and inside the data frame I will bring the two variables, which are what names and what age. This is it, names and what age, two of them. Then if I've done that, what will be the name of the data frame? I want to say let the name of the data frame be data. So if I go ahead and do this, if I go ahead and load it, this is age not found. Why is it not found? Object age not found, because I've not loaded it. I'll go back and say load names and also load age. So if I've done that, I will go ahead and click again. You can see now it's now activated. What if I want to now do something? I say, okay, what is data? I'm asking R now. Okay, what is data? It will tell me data is names and what age. It contains Image, Shima, and Ekene then with their respective age. What if I want to view it? I say view data, and if I do that, you can see it opens up a new tab and it's telling me it has names, age, Ima, Chima, and the same thing. So that is how it is. What if I want to know the class of names? This is the class of name, is character. What is the class of age? It is what numeric. And I don't want this to be recognized as a character. I want it to be recognized as a factor. How do I go about it? So I will refer to the variable I'm working on. When you go to the data, go to the variable called names and assign to it and use a function as dot factor, that is convert it to a factor. What will you convert to a factor? The variable called names. But before we get to names, we must pass through what data. So that is what we did here. And if I load it, if I go back and check the class again, the function that I did now, it is not a factor. So now another thing is that I built another data. This is a variable I named number, another variable I named gender, and another one which I named what complexion. So, and these are the three variables, and I now want to create a data frame with it. And if I create a data frame with, I want to store it in a name called skin color. So what are the things that are contained in the data frame? Number, gender, and complexion. So if I go ahead and load it, you can see I've done that. What if I want to know what is skin color? If I load it, you can see how it is. This contains number, gender, and then complexion. What if I want to view it? I'll say view skin color, and I'll load it. It opens up. This is skin color. You see how it looks like. It's up to 11. Okay. So another thing I want to do now, I want to check the class of what complexion. If I go ahead and load it, so another thing I want to do now, I want to check the class of what complexion. So if I go ahead and check the class of complexion, you see that is in character. Is it okay? No, I want it as recognized as a factor. So I change it to a factor. Let me go back and check the class again. It's now seen as a factor, which is good for me. So now the next thing we want to talk about is basic graphics. Now, first thing we'll be discussing is plot function. This plot function, it has the capability of plotting making a plot suitable for the data that you inputted in it. For instance, if you add a variable to it, it will automatically suggest the appropriate plot that is suitable for that particular variable. So for instance, we have a data called iris and we want to just plot it. If I say plot, it will go ahead and generate a plot, Ctrl Shift 6. So you can see now that this is the plot is giving us more of scatter plots because these are numeric, and when it got to species, it still went ahead to produce this. So now let me go back. So if that is the case, what if I want to just plot the categorical variable, and we are aware that the categorical variable there is species. So if I go ahead and say enter, this is it gave us a bar plot automatically. So, and if you are looking at these bar plots, Ctrl Shift, this is the bar plot. Is trying to tell that all uniform 50 50 50. We have setosa, vesicola, and vertical. But you find out that this plot does not have is not it cannot be easily understood because it doesn't have necessary labeling. So what if I want to label? I will say men equal to what? Let me call it species. Then I will say let the xlab be equal to, and for the xlab I will say names of what species, and then I will say let the ylab be equal to, maybe let me say count. So if I've done this, I will go ahead and load it. So you find out that our is Control Shift. This is it. You see that you have names of species, we have count, we have the title species, and it's more, I think is more presentable. So now the next thing we want to do again is that we want to plot the categorical and a quantitative variable. So let's see the type of plot. It will just go ahead and suggest Control Enter. So you see that it gave us it suggested what? A box plot. So we have setosa, vesicola, virginica, and then their respective this has to do with the category, the numeric variable which is sepal.width that is plotted on the y-axis. So you can as well go ahead. You already understand how to do the labeling. So you always make sure for presentation you must label your plots appropriately. So now, what about you want to plot quantitative variables? It's suggested a scatter plot, and this is our scatter plot. So another thing we want to go about is that how can we modify our scatter plot? For instance, we are still plotting for the two quantitative variables. This is sepal.width, and then our sepal. This is sepal.width, and then sepal.length. So, and then we try to give it a labeling. We say label is sepal.width versus sepal.length. What is the xlab? Sepal.width, and the ylab is sepal.length. Then PCH equal to 10 tells us the type of circle that should be used, and then color blue. Then another thing I want to say, let's say for instance we don't know what PCH is. So all I will do is I'll put a question mark, I'll write PCH. So if I do that, see Control Shift. So it's telling us, it will go ahead to tell us what it is all about. But where I'm interested in is that look at different numbers. You say when you use 0, it will use a square. When you use 1, it will be circle. When you use 2, it will be triangle. When you use 3, it will be plus. When you use 4, and a lot of other things. Let's use 8. That is asterisk. So I will use 8 instead of 10. Let me use 8. So if I do that, let me delete this. I will load it. So if I've loaded that, you can see this is 8. I used 8. You can see it's now using asterisk to indicate the points of intersection between the two things we are plotting, that is sepal length and then sepal width. And this is the title, and this is the color is blue. So that's how you can modify your plot for presentation. So having said that, we can also plot functions like cosine. We can plot cosine. This is how we can plot sine. We can plot tangent. We can plot cosine, giving its range from 1 to 2 times pi. That is the range. It will give us this. We can also plot density normally distribution, giving its range -3 to what 3, and this is it. So outside that, then the next thing we want to talk about here is bar charts, and we'll be using a dataset called MTCars. It's also contained in the package called datasets. So now let's quickly view how the data looks like. This is the data. It has a MPG, cylinder, display, horsepower, and a lot of other variables. So now if you don't understand the variable because they were written in short forms, you can still use question mark MTCars so that you can really understand the details about the data set. So now let me go ahead and see the head. This is something. Then having done that, I want to say, give me the structure of MTCars. So this is it. It has it has 32 observation and it has 11 variables. This is what I want to know, how many variables we have. So having done that, let me use a bar plot to represent the cylinder. Remember that now that the cylinder is what, if I go back to here, you can see that the cylinder, irrespective that it is written as a numeric variable, look at it here, it is being recognized as what, a numeric variable, but it is not a numeric variable. It is a categorical variable because this is trying to tell us the number of cylinders we have. We can have 6 cylinder cars, we can have 4 cylinder cars, and a lot of other things. So if I go back, let's just say I want to put it in a bar chart because it's a categorical variable. If I go ahead and do the bar plot, this is how it displayed it, which is not okay. So all I need to do is that I need to fix that particular variable into a table. If I fix it into a table, and I will name it, let me name it cylinder. So if I name it cylinder and fix it into a table, this is it. What if I want to know, see how it looks like now? I'll say, I'll type the word cylinder, which is the name. So if I load it, this is how it is now. It starts telling me that we have 4, 6, and 8 cylinder cars. That it now also gave me the frequencies. That 4 is 11. 11 cars are 4 cylinder. 7 cars are 6 cylinder, and 14 cars are 8 cylinder cars. So what if I go ahead and repeat the bar plot again? So I'll have here bar plot of what, cylinder. You can now see it is now okay. So but remember to always what, put your labeling. So you can modify it. You can modify the plot by saying that, okay, color each of the bars. We have 3 bars, so give the first one red, blue, and then green. Then we can say the title should be number of cylinders, the X lab should be count, and then the Y lab should be count, and then the X lab be number of what, cylinders. And I will load it. So you can see it has been, a title has been added and it looks better now. So having said that, I want to quickly go ahead to histogram. How do we bring up histogram? Histogram is usually used for quantitative what, variable. So let's say power.length is a quantitative variable contained in iris. Can we quickly look at the histogram? Okay, this is how it looks. So remember always to label appropriately. So what do you want to label it? This is it. So we can say histogram of power.length. Then what is the x-axis? Is power.length, and here is the frequency. So another thing we want to talk about is what about for that of power.width? This for power.width is almost assuming normal. If you are, this is almost like normal. So now what about petal.length? This is petal.length. But we notice something. There is a gap. There is a gap here. So we might want to explore the gap and understand what happened. So that is essence of histogram. Histogram will show you the distribution of the variable. It will show you if there is a gap, and it will tell you whether it is skewed to the right or left. So now another thing is petal.width, which is the last one. Petal.width, there is also a gap, so which can also be further explored. So now in this case now, if we are done with that, then I want to explore one of these, and the one I want to explore is petal.length, the first one that has a gap. So how do I go about it? There is something I want to explain. As I'm loading all my plots, it is showing one after the other. If I load another plot, it will override the other one and take the whole space. But I want to now partition my plot view into 3 rows and 1 column. The first one is row and the second one is column. So I will partition it into 3 rows and 1 column. So when I load this function, it has been partitioned now. So if I go ahead and replot this, it will no longer show the same way. Look at it. It will show the first one. It says too large. I can expand my plot view a little bit. If I go ahead and load this one, you cannot see, and this is so this is 1, 2, 3 rows and 1 column. You can see what I'm talking about. So I can clear it, but why I partition it, I wanted to use it to explore the gap that exists in this petal.length, this gap here. That's what I wanted to. So I can go ahead and delete the so if I do that, and it's clear. So if I have partitioned it, I'm interested to explore the gap that does exist in the petal.length. How do I go about that? I will now say plot the histogram of iris. Plot the histogram of what? Petal.length, and that petal.length is contained in iris. But first, when you get to this when you select this petal.length, select again species, but for that species, don't select. Remember, we have 3 species. Don't select the 3 species, only select Setosa. Do you understand? Go and plot for what? Petal.length, and for the petal.length, select petal.length for only species called Setosa. That is what it means. So that's what this functions, what it does. Then what is the title? I say give the title petal length for Setosa. What is the xlab? I left xlab empty. If I remove this xlab, it will just give it a default title. It will give it a default label. But now I don't want anything to be there. That's why I declared xlab, but I left it empty so that it will still be empty. So now color is blue, and what is the limit? X limit is 0 to 7. This X limit, I got it when I plotted the first this is petal.length. Let me plot it again. If I plot it, it runs from 1 to 7. This is where I got the limit. I wanted to now explore it each one after the other. This is where I got it. So in this case now, I'll go ahead and delete. Yes. So now, if I have done that, I will still partition. If I've partitioned to 3 now, so I'll say I partitioned to 3 because I have 3 what? Species. So if I've done this, I will load this first one, Setosa. So this is for Setosa. Then the second one will be for Vesicola. And then the last one will be for what? Virginica. And in the Virginica now, that's where I will now write xlab. I'll put petal.length, which will stand for all of them. So I'll say the last one is what? Virginica. And you can see now there is a xlab here, petal.length, which will go for all of them. So but here is empty for the xlab. So now you can find out that Setosa is a bit small. Then when Setosa could not, there is a gap. The gap existed between Setosa and Vesicola, but there is an overlap between Vesicola and Virginica. You can see from here to here there is overlapping, so there will not be any gap. But you find out that from here to before it gets to what Setosa, there is a gap, so it couldn't meet up. So the species, the length, petal length of this species, at this point it dropped before and went for there was a gap until then versicular species started coming up. So that is where the gap is. So you can use it to explore gaps. You can use it to understand the distribution of the variable, like a quantitative variable you are interested in, and many other things. So having said that, I can bring back my partitioning, my plot view partitioning to 1 by using, let the partition be row 1 column 1. So if I do that, it has the partition returns. So if I go ahead and make my plots now, it will be what? It will be presented as usual before, as it will be presented as usual. So that is it. So now, having done that, the next thing I want to talk about is data visualization using ggplot. So how do we, these are the packages you need to install for you to effectively follow. These packages has already been installed with Pacman in the beginning of this tutorial. So I just listed them for you to understand what ggplot requires to work effectively and all the other things we'll be using. So now, in using ggplot, there is something you need to understand. The first thing that comes in is data. Then the second one command that comes in is the mapping, and the last one is the geometry. The data is what data will I use to produce the ggplot. The mapping is that what will be the x and y axis. If I'm going to put the legend, which variable will I use to identify the legend? Then the geometry is that what type of plot will I do? Do you want me to do a bar plot? Do you want me to do a histogram? Do you want me to do a density plot? Whatever. So these are the 3 important instructions you need to give to what ggplot. So now, for instance, let me create data. In creating data, the first one is I call it number. I call the first one number, and I call the second one gender, and I call the third one degree. So now, class. I want to bring all of them to data.frame, which is and I'm calling that data.frame class. So if I say what is class now, I can as well go ahead and view it. I can say view view class. So this is class. This is what it looks like. It's up to, we have 10 observations. So if I go back, how do I produce a bar chart? A bar chart has to do with in this thing I'll say okay, bar chart is for categorical variable. So now if I want to produce the bar chart, I'll say ggplot. When I say this ggplot, it means the function will be active. I've already activated the function using Pacman. So I'll say ggplot. What will be the data? The data is what? Class. The mapping is what? The statistics is I say okay, use gender. The first variable that comes inside this statistics is the x-axis. The second one should be the y. So now I'm just declaring only one, meaning that this is the variable I want to bring in the what? In the bar plot, which is what? Gender, and it is a categorical variable. So now the next thing I said again is that what will be the what? I want you to use once you bring in gender, that's enough for a bar chart. But in this case, I want the height of each of the bars to be equivalent to what? The number. I want it to be equivalent to number. You understand? So in this case, I will be using the number for the y-axis. I will use the number for the y-axis. Then I'll say fill it with what? Degree. Fill it with degree plus. Then this one is a geometry. What geometry do I want to bring in? I want to do a bar plot. And inside that bar plot, I will declare start equals to identity. This thing means that let the height of each bar be equivalent to what? To the numeric y-axis. You know, this one will be for the y-axis. It is numeric. So I'm saying that let the height of each of the bars, let it be equivalent to this number that I will be representing on the y-axis. Then the positions to be what? Dodged. That means let them be positioned side by side. Then this is my labeling. I say let the labeling, let the title be what, degree level of participants, and let the Y be number of what, participants. Can we go ahead and do this? Then we'll now see how it looks like. This is a bar plot, Control 6. So this is a bar plot where it's trying to tell us that this is a degree level of participants, and these are on the y-axis is number of participants. Here is gender, and this is degree. We have female, and then we have male. So, and we find that this is the color code. We find out that this is people that have BSc for female. This is people that have MLC, and this is people that have PhD for the female. And the same thing happens here. I found out that MS is highest in both male and female, and you can explain a lot of things from these plots. So this is how to use ggplots. Then another thing is that there is a data called star wall, and what if we want to use inside that star wall? Can we see how the star wall looks like first? Let me say view star wall. So let's view the star wall. We'll say view, we'll say star wall. So if you do that, this is the data. This is how it looks like. It has variables, name, height, mass, hair color, skin color, eye color, birth, sex, a lot of, and then this is gender. This is where I'm interested. So, and several other variables. So this is the gender. Let's say I want to put up the gender in a bar plot using ggplot. This is ggplot star wall. Then another thing you need to understand from this first plot we did, for you to make it convenient, you can remove this data and remove mapping. So the time you spend typing the data and the mapping, you can remove it. The R will still understand that this class is the data, and this statistics is the X and the Y axis. If I go ahead and load this, it will still work. So this is it. So having said that, in this case I will no longer be declaring data and then the mapping. So here simply means that the first one is what, the data to plot with, and then the second comma, after the comma then the statistics. Now I'm just interested in gender and what type of geometry. I say use bar plots. So if I do this, you can see this is the plot, and you find out that we have feminine, we have masculine, and then there is NA not available, like there's some missing values. So it went ahead to plot it. So on that note, another thing, what if I want to make a plot for cpower.length using ggplot? So I will, cpower.length is a numeric variable. So I'll say okay, ggplot, go to data called iris. When you get to the data, the statistics should be what, cpower.length. That means I just need one. That means it's just the x axis that I'm declaring here. Then plus what is type of geometry, histogram. Then I say the bin weight is 0.2, fill with blue and then color blue. So if I go ahead and this is the histogram, then the bin, if I go ahead and increase the bin, let me say 0.8, you will see the difference. It will increase the bin, each of the bin, the size will also go ahead and it's increased now, and we find out that we are missing out some values. So that is by the way, let me reduce to 0.2. So you have the flexibility to adjust your plot. So another thing we want to do, what do we want to use ggplot and we want to make a box plot? So we say ggplot, use the data as star wall. A text should be height plus what type of plot? Box plot. That is what geometry is, box plot. What is the color? Give it blue. Then this theme should be black and white. Then the label should be box plot. This theme, I will explain what it is as let me load the plot first, then I'll go ahead and explain. So this is the box plot, as you can see. But something was we have a warning here. I say it removes 6 rows containing non-final values. So you find out that there are some that NA that we noticed when we plotted gender. We have NA, so not available. So it's also present in the height. So but it's automatically removed 6 of them before it generated this plot. What if I go ahead and remove this thing? What difference will it cause? Ctrl X. What if I go ahead and remove it and just plot this way? You will not notice the difference. This is it. You find out that the outline was not highlighted. So what that theme does, and what the theme does is that if I say plus and I bring back the theme black and white, it will give it an outline and put it in black and white. If I load it, you can see that this is it. You can see it's now outlined with what black and white color. So that is it. Then another thing I want to really talk about, which is very important, is using pipe operator. Pipe operator is a kind of a function that you can do a lot of adjustments to the data before it gets to the final task you want to do. Let's say you want to make a GT plot, a bar plot now, or a box plot. But before you get to the box plot, you can now adjust the data to the pattern or to the format you want it before it gets to what the last function, which is box plot. For instance, we said here, use the data called star words and means that what is the next line of action. The next line of action, we say drop NA. Drop NA means that there are presence of NA. That's why it's giving us a warning. When we just plotted with height, it gave us a warning that it removes 6 rows. Those 6 rows are the NA not available. There are missing values. So but now we are trying to tell we are giving a command that drops NA. Any NA that is contained in this height, drop it. So after dropping it, we say and then ggplot. That means make a plot. But you find out something here. Formally, once we write ggplot, the next thing that's supposed to follow is the data. But now we are not bringing in the data again because we have already declared the data. We've already started an action with the data here. So rather, the only thing we now say ggplot statistics is what? Use height. But this height that it will be using here has already been worked on. All the non-available values has been removed. Like NA has been removed. Use height as the x-axis plus what type of plot? Geo box plot. Make a box plot and let the color be blue. We also added the theme and added the label. So let's go ahead and do it. If we do this, we no longer receive the warning. It will just go ahead and make our plots. These are our plots. Because of what? The warning did not come up because now we've been able to drop all those NA that occurred in the data. So it makes our plot straight up. Then we can also use that pipe operator again. We say use a data called star word. In that star word, drop all the NA in the height. Then we want to filter again. We say filter sex, because now we also noticed that when we plotted sex bar plots, it plotted 3 bars. One is feminine, one is masculine, and another one is NA. But in this case, we want to filter that. When we want to filter sex only select male and what? Female. Don't select NA. That's what it means. Only select male and female. Then after doing that, plot a ggplot with statistics height. In that height, fill it with what? Sex. And the sex it will be filling it with is just male and what? Female. Then what? Color also with the sex, and then plus what? Geom under what is the geometry we'll be using? We want to make a density plot. The alpha should be 0.2. Alpha is about it will dictate the transparency of the plot. Then also use the theme black and white. So if I go ahead and run this, it makes the plot. This is the plot. So this is the plot. You can see the transparency. I can see through the plot. And this is the labeling, the X and the sex, female and male. You find out that there is nothing like NA here. It filtered it with only female and male. Let me go back. So what if I say let the this one be equals to 1? If I put alpha equals to 1, you will notice what will happen. It will become the transparency. Now it's not opaque. I can't see through again. So this is what the alpha does. So if you want to see through the other layer, then you reduce the transparency. Let the transparency be very small. Then let the alpha be very small. Then you see the transparency. So that is it. So another thing I want to say again now, what if you want to filter, you want to make a plot with a scatter plot. If you want to make a scatter plot, which of course a scatter plot is a plot of two quantitative variables, and then but now you want to say go to a data called star or filter the mass, all the mass less than 200. So there are mass that are up. If you go to the star wall, and this is the star wall, this is mass. So when you get to this star wall, you can see this mass is what 1358 is far more than, is more than 200, and a lot of other ones that are more than 200. So but here now we want to filter, we'll say use mass that are only less than what, strictly less than what, 200. And after doing that, make a ggplot using height and the mass, then color it by sex using sex, plus what type of plot will you do a plot of what, a scatter plot. What is the size? 5 alpha. You already understand what alpha is. Then what is the labeling? We did the labeling. So this is it. But you notice something here now, that this plot, since we did not filter the sex, it went ahead to tell us for the female, the male, the none, that means the missing values, and as well as the NA. So it reported almost 1, 2, 3, 4 for us, and then it went ahead to what, to this is the scatter plot using the mass and what, the height. Let me enlarge this. If you enlarge it, you find out that the mass will not be, there will not be anyone that is more than 200, which we specify. You can see the limit. It's 150 plus. If we did not filter the max less than 200, you would have seen it would have gone more than this. So that is what you can do with pipe operator. So now, because of that, let us filter. We say use a data called Star Wars, filter mass less than 200, and for the sex, filter for what, only male and female. Then any other thing that is the same thing as the one we did earlier, any other function below here is the same thing. So the only thing we added, we are filtering the sex now. So if I go ahead and load it, so you can now see that it becomes, now it is filtered for what, only female and male, and it is okay now. So the only then another thing is that everything is the same thing, but I want to add something now. I want to add a trend line, which I'll be adding with jump smooth, and then facet wrap. How do we wrap it? I want to wrap it with sex. So I'll go ahead and load this so that I can explain further how. So this is how it looks like. What it does is here is that it's trying to classify the male on its own and then the female on its own. Let me view it. So this it added a trend line to the female and then the male separately, because that's what the facet underscore wrap does. You can wrap it with a categorical variable, so it differentiates it among the classes that are present. So the jump smooth talks about adding the trend line. So every other thing is the same thing as I've explained earlier. So now the last session for this tutorial is hypothesis testing. Then we'll be covering t-test, ANOVA, chi-square, and then linear models. For the t-test, I use a data called Gapminder. Then I say in the Gapminder, filter continents. Let's first see how the Gapminder looks like. And I'll say view Gapminder. So this is how the Gapminder looks like. It has a country, continent, year, life expectancy, population, GDP per capita. So now these 1, 2, 3, 4, 5, 6 variables. I'll go back. So what I'm doing here, and I say go to data called Gapminder. When you get there, filter the continent. You know there are several continents in the Gapminder. If you see Asia, you see Europe, Africa, America, Oceania, and the rest. So now I say when you get to this continent, filter only for me Africa and what? Europe. And after doing that, then run a t-test using a t-test for the life expectancy in relation to what? Continent. What continent will it be using? The one I have already filtered that contains only Africa and Europe. What will be the data to use? I'll put dots. I'm putting this dot because I've already declared the data here. It is Gapminder, comma. Then the next thing, alternative, is that what type of test? Is it two-sided? If it's not two-sided, I can also put less. Less means that one-sided, or greater, that is the other left or right-sided. So, but now I'm doing a two-sided test. What paired is equals to false. So if I go ahead and do this, so this is the result. So in this result, now you say that the important thing we are looking at for here is the p-value. You find that the p-value is less than 0.05, which is a default level of significance. If it is less than 0.05, it simply means that the life expectancy of Africa and Europe are significantly different. Okay, they are significant. They are not just different, but significantly different. So go back. Then another thing is I can as well go ahead and say for the less. I've already said that if I'm putting for the less, it simply means that I'm being one-sided. Okay, it's no more two-sided. You can also put greater. You can try that on your own. Then another thing I did here is for ANOVA. Now I say go to Gapminder, filter continent. Now I'm making the continent to be 3. You know, ANOVA can always be used when you have more than 2 variables and you want to compare the means. So we have more than 2 variables here. Now we have Asia, Europe, and America. Then I say compute the ANOVA of what life expectancy in relationship to the what continents that have been selected. What are the continents? Asia, Europe, and America. All data, I put full stop. Then I also want to see the summary. So when I go ahead and do that, so this is the summary. I will still go ahead to I will quickly go to the p-value again. You find out that the p-value is significant. So it's significant, is less than the default p-value, which is 0.05. So since it's less than, it simply means that the life expectancy of among these 3 continents are significantly different. So go back to what we're doing. Then another thing you can also do here, you can add alpha on your own. Let's say for instance the first one we did, this is a t-test, and after declaring all these things, if you don't want to use the you can say alpha equal to 0.01. If you don't want to use the default is what? 0.05. You can still go ahead, it will go. So it simply means your alpha, when you are comparing your p-value, you compare it with, it should be now careful that it must be less than 0.05 before you say it is significant. So that's by the way. The same thing happens to the ANOVA. So now another thing I want to talk about here after discussing the ANOVA is chi-square test. Now the first one we want to talk about is we want to create a new data set. We say the new data set we are creating, we want to call it iris_data. Remember, there is a data called iris. We say when you get to that iris, mutate is create a new something, bring up a new variable. Mutate a variable called size. That means we are trying to bring in a new variable that we are going to call size. Then in that size, we say we are now interested in cpar.length. We say cut cpar.length into 3. Cut it into 3, and those 3 that you'll be cutting it into, label them small, medium, and large. So and after that the last one says select only species and the size. Remember now we are going to this data called iris. Inside that data we are going to create a new variable called size. Remember, the iris data has only five variables. Five variables ab initio. So now we are going to add another variable called size. And what will be the content of this size? What will be the content, the values that will be there? We say it will be cpal.width, but it will not just come as cpal.width. Rather, we are going to break this cpal.width into three. Here we'll name the first one small, medium, and then large. So, and then lastly, we want to select only species variable, and then the new created variable, which is size. Is what this code will do for us. So if I do it, a new data has been created called iris data. This is it here. So what if I want to view it? I say so after being created, it went viewing it now. If as I viewed iris underscore data, this is it here. It means that it has created a new variable called size, and it contains medium, large, and small. It tried to divide the cpal.length into three. It tried to divide it into three sizes, which are small, medium, and the large. This is what happened. And now the final command there is select only species and size, which is what it selected. So that means a new data has been created called iris underscore data. So in this case, we want to do a chi-square goodness of fit. Goodness of fit has to do with we're going to be selecting just the size. Yeah, that's what we are looking at. So we are it's just like selecting only we say go to the data called iris underscore data. Then when you get there, select only size. Then table function, we put this size into what table. It will make it it will now classify how many small do we have, how many medium do we have, and how many large do we have. That's how it will classify it. That means that is a categorical variable of three classes. So after doing that, it will not just do a chi test of goodness of fit among them. So that's what it will do. For instance, let me just say table open and close. I will say go to iris data, then $sign, because the iris data contains species and size. I will just say for size, I will say $sign size. I will select size and complete. This is what it will do. It's telling me small is 47 and the medium is 88 and the large is 15. Total of this should be 150. So in this case now, if that is okay, that's what this function will do, to classify them into this table. So after that, it will not just do a goodness of fit among them. So if that is the case, I will go ahead and load this one. So this is the chi-square goodness of fit test, and you can see that there is a significant difference between the small, medium, and the large, because this p-value is less than 0.05. Then another thing we need to talk about here is test of independency. The first one will be this goodness of fit test, which has to do with just a column. It has to do with column that contains variables. It contains medium, it contains small, medium, and large. But now, when you want to do test of independence, chi-square test of independence, it must have column as well as row. So in this case now, you find out that we will now be doing iris data, iris underscore data. Are you getting it? And then it will put it in a table. And after putting it in a table, it will do the chi-square test. Let me show you what it looks like. If I just say table, remember the other time I said table, and I just selected the variable of interest, which is size. So if I say table now, I'll just say iris data. I'm not being specific about a variable now. I'm just talking about the whole data. If I load it, this is how it looks like. This is column and this is what row. You understand? So these are the points of intersection. The setosa that are small is 1, vesicola that are small is 27, vaginica that are small is 19, as well as setosa that is medium. So there is a point of intersection between the column and then the rows. So this is a test, chi-square test of independence. It will compare the two. It will compare the size against and the species. So That's what it does. Unlike the other one that compared only size. So just try to understand the difference. So this is what it will do. It will go to data set called iris data, and it will just put it in a table format, which is just this format we are seeing here. This is a table format. It will put it like. After putting it in this format, then it will conduct chi-square test on it. So I'll hide and load this. So when I do that, this is it here. It is still also, it's also significantly, the species and the size are significantly, there is no dependency. Are you getting it? There is no dependency in two of them, so they are different. There is no dependency. So among the two variables, which are what and what, the species and what, the size. So now the last but not the least we'll be talking about is the linear model. We will be using a data that is called cars. It's also contained in the dataset package. So this is how it looks like. It has two variables, speed and then distance. So once you now conduct, we say we are using a pipe operator. We say use a data called car. When you call up the data, then conduct a linear model, put up a linear model using the distance to the car, distance and in relation to the speed, and then the data should be already, I will declare the data, and then give us the summary. Now you'll find out that the distance that will be covered is dependent on the speed. So the distance, the first variable that comes in is the dependent variable. Then the next one that follows will be the independent variable or variables, as the case may be, because this is a simple linear. So it contains only one independent variable. If I do that, this is how it looks like. So let me quickly explain some few things that are important here. The first thing you look at here, you find out the intercept and the coefficient. These are the two things. Two of them are significant, under 0.05. Then another thing you need to look out for is the R squared. So looking at the R squared now, you can see it is 0.6511. Then what simply means that 65% of variability in the dependent variable was explained by the independent variable. 65% of variability in the dependent variable. What is the dependent variable? Distance, was explained by the independent variable. This is also the adjusted R square. This adjusted R square will reduce when you have much irrelevant independent variable. So at this point, we want to say thank you for coming to our channel, and we want to remind you to also subscribe for more resourceful videos, and thank you very much.